being somewhat smaller, especially the right frontal lobe, being somewhat smaller in ADHD than in controls. These are the basal ganglia, which is where the frontal lobes project down to in organizing systems for the brain. And this is the midline of the cerebellum, and I don't think any of us know exactly what the cerebellum is doing, but it's got more neurons in it than the rest of the brain, so it's certainly doing something important. And these are the areas that tend to be smaller. It's not a diagnostic for the individual, it's a group effect, and there's a lot of overlap. So we can't say from the scan whether a person has ADHD, but we can say that as a group, people with ADHD have brains that are somewhat different in their structure. Just to put it diagrammatically, the frontal lobes projecting onto these basal ganglia deep in the brain. It's a kind of loop that you use to inhibit behavior. And this is a scan of the brain. This is the front of the brain. This is the right side, that's the left side, an oblique view. And this is the activation of the brain that comes in functional imaging, which is where blood with oxygen is arriving in the part of the brain that's being active. So as you can imagine, hemoglobin has got iron in it, fixed to the oxygen. That's quite a strong magnet. So it's creating a strong magnetic signal about the parts of the brain in which blood vessels are opening up and delivering oxygen. So while we don't know everything about what the physiology of this is, it's called bold activation, and it's been a powerful tool to think about what's happening in different areas. And you can do it while a child is doing something. This is the kind of test in which children have great difficulty if they have ADHD. And what they're doing is that if the arrow says left, you press the button on the left. If the arrow says right, you press the button on the right. But occasionally,